Before we get to the actual lab, I thought we'd warm up by explaining some things in the kitchen. So relax, I'm going to teach you the solution to the magician's trick even before we see the trick itself. This is a wet chemistry lab. It doesn't involve mixing and compacting solids. This is as basic as wet chemistry gets. To speed up the process a little bit, pre-crush any clumps you see. Let me add hot water to both beakers or glasses so that the solids dissolve easier. Here's the key sentence or trick explained to this entire process. I'm going to mix these two solutions together using an eyedropper to control the rate of reaction. It's not going to explode, foam, fizz, or produce any gases. In fact, the only color change you'll see are some small white crystals will appear every time you drop a little chemical into the large beaker. It kind of looks like a snow globe. But the overall task is dirt simple. You're going to take an eyedropper and move the contents from the small beaker to the large beaker until it's empty. I'm going to superimpose this graphic when John does his lab to remind you just how simple it is. A little bit more difficult than that. One is if you use the spoon for this chemical and putting it in here, don't use the same spoon for this one. Use its own dedicated spoon for this one. This is just sugar. This is Kool-Aid. You want a dedicated stir rod for your small beaker, and you want a different stir rod for the big beaker if you need to manually stir them. Stir and heat both beakers until all of the solids are completely dissolved before you start the eyedropper transfer. A big rule is to keep your eye on the small beaker. You only want to transfer clear liquid from the small beaker, transferring it over to the large beaker. The eyedropper must always be void of solid material. Initially, this will be easy, but toward the end of the lab, either the white crystals never dissolved or they'll start appearing on their own. The neat thing about this lab is you can merely add more water, heat it, stir it some more, and those crystals will eventually dissolve. You can then resume with the eyedropper transfer until the beaker is empty. If you do happen to pick up some solids, no biggie. Just spit them back into the small beaker and try again, or, like I said, add more water and stir. And the other is, why do we drop around the clock? And the answer is pretty simple. We want to distribute or broadcast the lead nitrate over a large area. In other words, we don't want to concentrate it. This is analogous to spreading out grass seed in your yard. You want to broadcast it over a wide area, right? If you got a big full vortex going on in the big beaker, then dropping around the clock is not necessary. I just do it out of habit. The question I'm asked the most is, how fast can I use that eyedropper? At what rate can I drip those drops? And I want to answer that question once and for all. And the answer is, it's not a squirt. Squirting is definitely not allowed. And it's not 1, 2, 3, 4, 5, 6. Nor is it 1, 2, 3. That's too ridiculous on the other side. It is a casual drop where you can count each drop out loud. 1, 2, 3, 4, 5, 6. That's a good rate. Make note that the lab is in grams, not grains, so switch your scale appropriately.
We're going to start with the sodium hypophosphite, 21.5 grams of sodium hypophosphite. So in the lead nitrate, it's a little different. So it gets kind of clumpy. So I like to shake it up really good first. We need to grind 33.1 grams. And then we're going to start grinding. Grinding here to make it nice and smooth so it will dissolve very quickly. We're going to put our small beaker up on the hot plate, and we're going to put our large beaker up on the hot plate. And we want that large beaker to be just a little bit off center on the hot plate.
I feel I need to interject real quick. This is a good overhead view of John's hot plate stir. John's got the Mac Daddy of all hot plate stirs. I bet you paid almost $200 for this particular hot plate. It even counts the number of revolutions for you. It's gorgeous, actually. I'm jealous of it. The hot plate stirs that you and I will own will look more like this in the $50 range or so, and there's not going to be that much room. Our hot plate stirs are only going to be about this large. If you look at his hot plate stir, see how this extra room he's got? We won't have that luxury. So our hot plate stir, the heated portion, will only be this large. So you're only going to have enough room for the large beaker with your sodium Hippo, your lead nitrate in the small beaker right here, and what I call the booger. It's a little 50 milliliter beaker that I like to hold in reserve. It'll just hold extra distilled water in case you need it for either beaker during the lab. I don't like pouring cold water into my lab because then I got to wait around a few minutes. The way these hot plate stirrers work is there's a little magnet that twirls around in the exact middle of the hot plate. It will rotate these magnetic stir bars that you put in there. It'll automatically stir the contents very nicely for you, and it'll also heat the hot plate to a given temperature, do all the stirring and heating for you. Now, because it is in the direct center and we have a crowded hot plate stir, you're probably going to wind up where the sodium Hippo is the only beaker that's going to have a stir bar. You're going to stir the lead nitrate in the small beaker manually with a stir rod. That magnetic stir bar probably won't be there. And this beaker will probably go more toward the center of your hot plate. Let's get back to John's lab.
I've got my magnetic stir rod in my large beaker. And the first thing we're going to do is we're going to put 130 milliliters of water into our large beaker. And we're going to put 60 milliliters of water into our small beaker. Temperature probe in the small beaker. I've got my magnetic stirrer in the large beaker. I'm going to go ahead and turn on my stirrer. Well, our temperature has reached 90 degrees Celsius in our small beaker. So now it's time to add the chemicals. First thing we want to do, though, is we want to speed up our stir bar to where it's creating a little bit of a vortex in the beaker. Really, you want that stirring as fast as it'll stir without splashing water out, because what happens is as we start the transfer process, the density of the large beaker will start to get thick.
Question: in which beaker does the lead nitrate go? The answer is A, the small beaker, B, the small beaker, or C, the small beaker. The lead nitrate goes into the small beaker.
And I like to do this, adding chemicals with a spoon to start with, so I'm not plopping. And with the lead nitrate, you want to pull up your stir rod right away. Stir, stir, stir. All right, so I'm going to continue to add my lead nitrate. And you just want to be gentle, take your time, stir that good. And we want the lead nitrate to dissolve and remain dissolved, and it's going to resist that. The lead nitrate is kind of the one you really have to watch early on, and I want to stir, 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 stir. We are there, so now we can start adding our sodium hypophosphite. All right, so that's stirring.
Now, he did his one chemical at a time. Of course, you can add the lead nitrate into the small beaker the sodium Hippo into the large beaker and start heating them and dissolving those two at the same time rather than working on just one at a time. Okay?
Okay, so our temperature's up to 86 degrees. Nice and hot. And the most important thing here as we think about getting ready to transfer the lead nitrate solution over to the sodium hypophosphate is that we don't want any particles in our dropper. All right, so that's nice and clear. No particles inside. The other thing you want to be cautious about is don't stick your dropper all the way to the bottom of the small beaker. Just watching that we don't get particles in there. And you can see how the sodium hypophosphate is changing to an opaque color. And that's exactly what you want to see happen. So we're going to keep doing this for a while, come back and once it thickens up a little bit. Continuing the dropper on the clock, I added another 5 milliliters of water and reduced my hot plate temperature. It's still back up to 95. Okay, we're going to add just a little bit more water. Give it just a minute here. Got our vortex. The big beaker is like a glass of shiny milk from top to bottom. Okay, I'm going to keep dropping. It's hard to see, but there's a little skim on a small beaker, so you just got to be careful that you're constantly stirring this. And as long as we can dip below that skim, well, you just want to make sure it's all stirred up, but you just got to be careful that you don't suck up a bunch of particles. If you see where you suck them up, then just squirt them back into the small beaker. And we continue to drop. We'll add a little bit more water for good measure. And then you can start to see how it's stratifying. See how it's stratifying? There we go, got it going again. Got to remember to keep my stirring sticks separated. So our lead nitrate, small beaker's doing okay. And I'm trying to minimize how much water I put into small beaker because that just slows down the process. Okay, so we're getting down to the bottom, pretty much just clear. And there's really nothing much left in this small beaker except water. Okay, be back when we're done here. Okay, so we're finished up all the lead nitrate. So we're going to cook this for a while. At 75 degrees. We're going to cook this for at least 10, maybe 20 minutes. Well, we've turned the heat off, and you can see now how the solution is stratifying, and still some snowing going on in there, how quickly it settles. All those crystals are exactly what we're wanting.
We're going to let this cool naturally to room temperature, and by doing so, it will form nice big crystals that will be later caught in the coffee filter. You'll notice this differs from Marshall's lab, where we're going to skip the ice bath because I don't think it's needed at this point in time. This will save you roughly an hour in time, and it's always been my goal to show you the easiest way to do things if it doesn't hurt the quality or safety of the lab.
So the next step is to transfer our lead hypophosphite into the funnel with the filter.
This is an excerpt of Marshall's lab. He's the author of the homemade primer course.
Well, while we're waiting on that, let me go ahead and fold up a piece of filter paper. It's just standard coffee filter. And to make it fluted, you just kind of make a pie and follow it back and forth around the filter. Yeah.
If you want a swan, I can get my mom to do a swan for you.
Okay. Well, it's not origami. It's about right for that. Yeah. So when you open it up, fills right in there and ready for you to start pouring stuff in there to collect.
You can see Marshall use water to make the funnel stick to the plastic funnel. Common sense stuff.
All right.
Where that is. See those great big crystals in there? That's what we want. I've got some in a little squirt bottle.
This may sound strange, but the water in the squirt bottle does not have to be distilled water, but it does need to be cold. So use cold ice water from your freezer. You don't have to freeze distilled water and things of that nature. That's not necessary because the chemicals have already done what they're going to do, and tap water won't hurt anything.
Do you see how nice and gentle that is? Again, we're taking our time. I think I got it all. And that wasn't hard, right? Alrighty. So you can see the nice big crystals. That's lovely. So now we're going to do our first rinse. And all we want to do is we're going to gently spray light stream of water. And we're just washing this basically. See how gentle that is? And you tap. We'll let that drain. We'll be right back. Okay, here's rinse 2. That's rinse number 2. Okay, last rinse. Okay, we'll come back as soon as this drains.
This is a quality checkpoint. The water or the liquid below the coffee filter in the flask should be clear. If it's cloudy, something went wrong, but I've never seen this happen to anybody.
We're going to transfer the lead hypophosphite to the paper plate. We're going to gently kind of peel it away from the side of the funnel, drag it out onto the plate. And we're done with that. We're going to gently make a daisy. Pull this apart and lay it flat on the plate. And what we're going to do with our spoon, we're just going to spread this out. You want to keep it on your filter paper. And what this will do is it will help your product dry. So again, that's why I like a red spoon. We just have to set this aside to dry. It's going to be a very light powdery substance. Get you the edge of the paper here, and you're just going to lift it up, and it'll cause it to fold over and crumble. You can use a business card and just chop it up, lift the edges and roll it over on top of it, because it's very, very fine, fluffy powder when it really dries out. And that's it.
The final topic I wanted to cover is, why does John's lab and Marshall's lab look so different? And the answer is water. You see, Marshall added much less water than John. Therefore, Marshall's going to produce a little bit more lead hypophosphite because he ran his lab more concentrated. But because this lab is so forgiving, both gentlemen will produce enough lead hypophosphite for roughly 3,500 small pistol primers. Enjoy. This is Mark on aardvarkreloading.com. We are growing. We now have 3 MeWe groups in which to choose, a primer library to help keep track of the information, and now a Microsoft Teams area to meet virtually. Making several hundred primers in an afternoon is not only possible, it's becoming more and more routine.